All right, if you look at this problem, they also tell us something about parallel lines. They tell us this line is parallel to this line. So I know that if I'm going to do this problem, I'm going to need to know something about two similar triangles because we know we're doing similar triangles here. So since I have this line parallel to this line, couldn't I get two triangles parallel? If I cut this transversal right here, wouldn't that mean that this angle is going to match up with this angle right here? Y'all see what I'm doing? When they tell me lines are parallel, they're really trying to tell me something about angles, okay? They mark the lines, but they tell me these angles are parallel. And then I also know that this angle right here in green is congruent to that one by vertical angles, right? So these two triangles, let me outline in yellow. This one right here and this one right here are similar. So that's what I'm going to use to solve this problem. They put extra stuff in there just to see if I can pick out the information that would, to find the similar triangles. So here's what I'm going to do. I'm going to take this lower triangle and I'm going to draw it like this, 6x and 5. And then I'm going to take that top one and I'm going to draw it the same way so I can match up stuff. Now, what does y match up to on the upper triangle? Y matches up to what on the lower triangle? 6, because the angles kind of are across from each other. So y matches up with 6, so I want to put y right there. I know that x is going to match up to 14, so that must mean 10 is over here, right? So now if I want to find x and y, I'm going to make proportions, but look at this. These two sides are matching up, aren't they? Can you tell what the scale factor is already if you don't want to do a proportion? How do you get from 5 to 10? What do you multiply by? 2, right? So if you want to know what y is, wouldn't y be 6 times 2, right? So y would be 6 times 2. If I don't want to do a proportion, I can see what's going on here. So maybe I don't go to all that trouble. I just double 6. Is that confusing anybody that I'm doing it that way? Isn't it kind of nice when you see what the numbers are, how they relate from one to the next, so you don't have to set the proportions up? What's x going to be? If this one's 14 over here, what would x be? Since I'm going from the big triangle, little triangle to the big triangle by multiplying by 2, what times 2 would give me 14? 7. So we know x is 7. I could have used proportions, but if I see the scale factor is 2, and I can see it because 5 times 2 gave me 10, then I can just, 12 and 7. I could get them really fast. I don't even have to do the proportions if I don't want to. So if you notice something like that, that's always the fastest way to do it. But still, didn't it help that I redrew it, turned them to face the same way so I could easily see what matched up across the triangles? Some people don't have to do that. I do, guys. So, and when you do it, sometimes you find that a problem's not as hard as maybe you might think it is. If you see that times 2 there, it really makes everything go quicker. Okay, so if you look at this problem here, they've given you two triangles, and we notice they want to know, it says solve for the missing triangle measurements of each pair of similar triangles. So we already know they're similar. That's good. What I would suggest you do is maybe draw it out and make the bigger one match the direction the little one is sitting, just to help you a little bit. So here's 70 degrees. Man, I can't read that. Y, let me try that again. 70 degrees is where the dot is. You've got 34 out here, 28 out here, and 40 down here. If I redraw the big one and make it sit the same way, my 70 degree angle is E, isn't it? And B is 70 degrees. So let me draw it where E and B match up. If I look at the statement over at the side, they tell me ABC is similar to FED. So they're telling me how it matches up. My A is the first letter in ABC, so it's going to match up with F because that's the first letter in the second statement. So I know that I should draw the second triangle like this, FED. And the reason I knew it is just looking at the way, the order of the letters in this statement right here. Okay? So that's going to help me get started. Let's see, if I put the 70 degrees there, D was 30 degrees, and F was congruent to Y. So we know F and Y are the same thing. By the way, I can already tell you, we can already figure out that Y, because let's look at the big triangle. We got 70 degrees, we got 30 degrees, so that's 100 degrees. They have to add up to 180, right? So what is that missing one going to be down here? 80, 180 minus 100, right? So this is 80 degrees, so isn't Y congruent to that angle? We drew them, we marked it. Y is going to also be 80 degrees. So just situating them where they're standing the same helps a little bit, okay? All right, so now we know what Y is. We're supposed to find X also. Oh, they told us some sides over here that I didn't mark. EF is 42, and ED is 51. How am I going to find the scale factor? That was another thing they asked me for. Okay, yeah, find a side that has the numbers on them. Let me use yellow to highlight. Don't I have a number here and a number here? How do I get from 28 to 42? Couldn't I say, well, take 42 and divide it by 28 to see what that comes out to? 2.175. Okay, let me just, I'm going to do it as we go too, just to make sure that. Yeah. I got 1.5. Okay, yeah, 42 divided by 28 would be 1.5. So scale factor is 1.5. So that's another thing they wanted, right?
I think I did it with the angles.
Oh, okay.
Yeah.
All right, now we got to find X. And X is this big old section right here between F and D. I can make a proportion, but if I know the scale factor, couldn't I take 40 and multiply it by the scale factor to get what X is? Right? Would that be the faster way to do it? I could say 40 times 1.5, which I think is going to be, wait, let me just, I don't trust myself. I was going to say 60, but, oh, it is 60, okay. So I could get it that way. If I want to set a proportion up, I could say 40 matches up with X the way that maybe 28 matches up with 42. So if you like proportions better, or if you understand them better, you can still use that. I'm just saying there's a faster way to get there, right? So let's solve it and just see. We get 28X. Let's see, 40 times 42 would be a 0, an 8, and a 16. 1680. So if I divide 1680 by 28, because I'd have to divide both sides by 28, I would also get 60. Okay, so I can use the proportion to get it, or since they told me to find the scale factor and I already found it was 1.5, I could say 40 times 1.5, and I'd get 60 that way also. So there's more than one way. If you can tell what the scale factor is, you can just use that and multiply the little one times that number to get the side that matches up on the big side, big triangle. So that's kind of nice if you don't like the proportions. Okay, so 7 shows this figure. This figure looks like something that would be on a test to me. This one. And they tell us a lot of information, so let's go label it. BC is parallel to DE. Okay, that means that I've got a bunch of angles matching up, don't I? That means this angle and this angle are congruent because they're corresponding angles, and this angle are congruent because they're corresponding angles. So I know that that little triangle and the big triangle are going to be similar. I could always use proportions to solve it that way. I have another way to look at this problem also. Because this line and this line are parallel, I could even say these little pieces are proportional. So I've got a couple of ways I can solve this problem. Let's label everything and see what might be the easiest thing to do. AB is 3, BC is 4, AE, the whole thing, is 16, and DE is 12. Should I use the fact that those two yellow lines that I marked are parallel? Is that going to work very well for this problem? Why not? Blake, I see you shaking your head. Why do you think it wouldn't work well?
I didn't see it on my
Oh. Anybody got a thought on that? As a matter of fact, looking at similar triangles is nice because didn't they give me the whole side AE 16? So that's kind of handy that's that whole big side. And I have this big side down here. Isn't this big side 12 right here? And then I know on the little triangle that AB is 3 and BC is 4. So that'd be kind of handy to look at it separated like two triangles. They want to know what BD is, just this piece right here. So I'm going to call it X. On the big triangle, wouldn't that be this side? I'll highlight it in green. Wouldn't that make this whole side right here X plus 3? I'm going to say 3 goes to X plus 3. Let's see, 4 and 12 match up and they both have numbers, you know, that little base piece. So wouldn't that be handy to use 4 and 12? Am I using 16 at all? Not really here. So if I cross multiply, 3 times 12 is 36. And now be careful here, when you cross multiply here, that's 4 times all of X plus 3. So you have to say that's 4X plus 12, isn't it, when you distribute? So now if I want to solve for X, I'll subtract the 12 first. 36 minus 12 is 24. That's equal to 4X. If I divide both sides by 4, see if I can cram it in there. What's X going to be equal to? Wouldn't that be 6? 24 divided by 4 is 6. And that X right there was BD. That's what they wanted to know, was BD.